Okay, so why we need to build, or why you need to build your own container? Well, there is system-wide installations of OpenFOAM for version 5 and 6 in Magnus and SUSE. There is already these containers for the latest versions of OpenFOAM and some older versions of OpenFOAM, not all of them. So if you have never installed OpenFOAM in your own computer, this episode may be a little bit difficult to follow because it deals with basically with two things. One is how to install OpenFOAM, and on top of that is how to do it with Docker to build an image that has OpenFOAM inside. So it's twice complicated. So we have already passed this stage of connecting to the virtual machine in Nimbus. So part A is already covered. So now you can go to, well, it's not completely covered because I need to do it myself here. So I'm connecting to my Linux computer. Now, I already did a bit of the next steps. So the next step is, well, you can create a directory, or you can basically clone the Git repo of the scripts and the exercises directly there. But what I'm suggesting is to create a directory. So mkdir Pawsey training, then cd into Pawsey training, and then git clone, again, the repository of the exercises. So by pressing enter, you will generate the directory of the scripts down there. So I think I'm going to do it. I'm going to remove what I have here. I'm going to do it myself again, just to start clean. So I copy the command, git clone, and the repository. So there we are. So now we have the scripts there. And then we can jump directly to the first exercise, which is building a first Docker image with MPICH. So this build is not going to be the full building of OpenFOAM because that takes a long time. For me, it takes around 6 hours in these kind of computers. So we're going to be just building a small piece of the total recipe. So,
sorry, Alexis, to interrupt.
Yeah.
I just came into the room. If you can help me finding the link to this help document session that I can copy paste commands from, that would be greatly appreciated.
Yeah.
So if you just put it in the messages,
I'll do that.
Yeah, it's going to be.
Thanks.
It's going to be in the chat, and then you go to episode 4, and we are right now in section C.
Okay.
Okay. So yeah. So we cd into the containers directory, and then to episode 4. I forgot to add the shrinking, the command for shrinking the prompt. So that's, I think, oh, it's here. I'm sorry. It's cold start today. Okay. So cd OpenFOAM 2.4.x. So the version of OpenFOAM we are going to do today is an old version of OpenFOAM. So it's 2.4.x. So that's all versions are, I think, better candidates to need to build the containers. So that's why we are using this old version, 2.4.x. And then we have the same structure that you will find in our Git repo, which I will show you later in the session. But there are two directories. One is the 01 Docker and the other one 02 porting to Singularity. So in 01 Docker, there is the definition file. That is the Docker file for creating the image in Docker. And in 02 porting to Singularity, there is the definition file to basically convert the Docker image into a Singularity image. So right now, the prompt is too large. So please copy paste the command in the point 2 in the tutorial to reduce the size of your prompt if you want. Okay, so now getting into business, let's see what we have in the Docker file.
So just one question on where the tutorial is.
Yeah.
I think up in the page there is a reference to home Ubuntu Pawsey training. That's not relevant on Nimbus. You can just git clone the repo wherever you want. So this is to answer a question by Ali Reza on the chat.
Yeah, exactly. You can clone the repo wherever you want. There's no issues with that. Okay, so now let's get into business and see the first Docker file. So you can, well, we can see what I have to discuss in the tutorial. So if you basically come back to the Zoom window and watch my screen while I discuss what is in the Docker file. So there are several sections. So the first one is the top one section. And basically the first command, this is not bash or Unix. These are commands from Docker. So the first, the hashes are command lines. And the first command is this command from. So when we say from, we're telling Docker to build this image on top of a previous image. And that's a very common process. So the previous image that we are going to use is an image that has already MPICH installed in it. So in our Docker Hub repository, the one of Pawsey, we have this image called MPICH base, which is tagged, or we can say the version of that image is giving us a little bit more of information. So this 3.1.4 is really the version of MPICH that is installed inside the image. And then subindex Ubuntu 16.04 is telling you that that image was based on top of an Ubuntu 16.04 image. So basically, we are going to build this OpenFOAM container on Ubuntu 16.04 using MPICH 3.1.4, but we are not going to bother installing MPICH. That is already installed in this previous image. And then some other commands that I'm not going to discuss very much, but this command that is arg or argument allows you to have like local variables. So these variables are not going to be defined at the end in the image or the container. These are variables that are only usable during the recipe. So it's not an environmental variable for to be kept. So here I'm saving the version of OpenFOAM we are going to deal with. Then there is another part where we can start installing stuff on top of what we had before. So this is the type of syntax that we use for installing stuff. So the usual command in Ubuntu for installing packages is apt-get. And in the recipe, we say, okay, run this command. So basically we're saying run apt-get. But instead of saying run apt-get update and then run apt-get the next command and then run apt-get clean all, we are chaining all these commands with this double ampersand, so that at the end, all this is executed in a single run, in a single Docker run. And that is to save size and space in the structure of the Docker image, because each of these run commands are saved in a layer of building. So if we do several runs to execute this, we will have several layers saved, and that will take a lot of space. So this is basically one of the best practices recommended for building Docker images, to conglomerate a series of commands into a single run Docker command. The way of doing it is basically with this double ampersand, and in order to make it readable, we are breaking the lines and continuing in the next line with these backslashes. So this backslash is, that is not Docker language, that is Linux language. So from run space and from here to the end is bash language. So all this bash language is going to be executed in this run Docker command. So, well, these packages I think are important to have in the container, so that's why I added them. And then that here is in section 3 of the Docker file is basically where the installation of OpenFOAM starts. So I'm adding inside the Docker file some comments about the sources I used to define this recipe. So in the case of 2.4.x, which is an old version, it's a bit difficult to find some information from the official developers of OpenFOAM, but it's good that they kept their instructions for building the old versions there. So in this case, from the OpenFOAM Foundation, you can search, and after a while surfing in their site, you will be able to find some instructions for, not for 2.4.x, but for 2.4.0, which are in this place. But also, and this is the more important one, you can find instructions for a lot of older versions of OpenFOAM on how to install them in the OpenFOAM wiki. So this is the address for the instructions of installing OpenFOAM 2.4.x for Ubuntu 16.04. So that's fantastic to have. And that is the main source of information on how to build your recipe. These instructions are not for building containers. These instructions are for installing in a normal installation in a Linux environment. So if we go to those instructions, you will notice here, so instructions for 16.06, and then you will see that you need to execute apt-get update, then apt-get a series of packages for Ubuntu environment, and then a series of steps to be executed for building or well, for installing OpenFOAM. So basically what you do in this Docker file recipe is put all these series of steps in the recipe inside Docker run commands. So just to notice that the first part is to install this series of packages. So, well, just the final part in this section, I'm defining again another argument to the place I want OpenFOAM to be installed, and to the place I want OpenFOAM to recognize material or stuff for the users, like your own solvers, your own libraries, etc. And then this command is important, the work dir. So work dir is this command for the Docker recipe that creates the directory you tell the recipe and cds into that directory. And if that directory already exists, it only cds into that directory. So basically, it tells that the next steps until it finds another work dir are going to be executed in that directory. So basically, I'm creating and changing into this directory, opt OpenFOAM, which is the place where the installation is going to happen. Funny, change a little bit the font here, but this is, I think, almost the last bit I'm going to show you for this first part of the recipe. So then this is the first step in the installation of OpenFOAM, which is installing all this series of packages. So as you can see, I have this run command and then apt get update, and then chaining that with the next apt install command, and then the series of packages that we were told in the wiki or in the instructions from the developers that needs to be installed. There are some exceptions, and I'm not installing everything. So wherever you find comment starting with AEG, those are my initials. That's saying that I'm writing that comment just to notice that I was the one who wrote that comment. But basically what I'm saying here is that we are not going to install OpenMPI in the container or the image. Well, in the image. So this was part of the original recipe, and basically we are commenting that part. And then there was another part saying to install libscotch, and I needed to put that out because libscotch has some dependencies, and if you install libscotch, that installs again OpenMPI. So I need to remove that. So that is the main point here, no OpenMPI. If you are reading the recipe of the Docker files that are in the exercises, most of this part is also commented. So build essential is commented. Basically, most of the lines, I'm just leaving on this line, which is the line that has the installation of Git. And that is just for saving time, because all the installations of all these packages takes a while, and it will kill some time for the exercise. So that's just for the exercise, but officially should be like in the tutorial. And then the last bit that we are going to use in this first part is cloning the source files of all the installation of OpenFOAM, basically download OpenFOAM before compiling. Okay, so what we're going to do is basically execute the build of this first recipe. So the command is like this: docker build, and then tell Docker which file it's going to use for building the image. Usually we don't use this part, this -f Docker file, because by default it will pick a file named just Docker file, but we don't have it there. So let me go to the 01 Docker, and there you see we don't have a Docker file by itself. We have Dockerfile 01 and Dockerfile 02. So in order to use Dockerfile 01, we say docker build, use this -f is to use Dockerfile.01, and then we tell the builder what is the name of the image we want to create. So in this exercise, I'm saying my user and then OpenFOAM. So this is the equivalent of Pawsey, or in my case, Alexis Espinosa. This is basically the account you have in Docker Hub. So we are not going to show you here how to create an account in Docker Hub, but that's very straightforward. But you need to use the same name as your Docker Hub account, because at the end, what we are going to do is to push the image into Docker Hub, and you will use the same name of or same username. But in this case, I'm using just this general my user, and then the real name of the container, which is OpenFOAM, and then a tag for that specific image of OpenFOAM. In this case, I'm just saying 2.4.x.01, just because this is not the final image we are looking for. This is just a test. And then the Docker build command needs a path to look for some other stuff. So you need to tell where to look for that other stuff that we really don't have here, but we just still need to define a path. In this case, we are saying this place, that's the dot, that's the meaning of the dot. Then enter. So now we have built our first image. This is the process, and to see if that image exists, it is not there as Singularity do. Singularity can build your image in your working directory. But in this case, we need to check the list of images available by the Docker engine. So we do docker image ls, and then I have a list of images there. So some of them were previously installed in that Nimbus instances. But you will see that now we have this my user OpenFOAM 2.4.x.01. And this was created 2 days ago. I did not remove it, but for you guys should be created just right now. And that's it. I think it's time for questions.
Yeah, so we have a couple from the chat already. So one was more like Linux related, but I think it can be of general interest. So actually I was asking, what happens is when you do apt-get install of some software that will ask you questions during the installation procedure. And so I posted on the chat a syntax that you can chunk in the run block to avoid that. So you can define a variable named Debian frontend, and you assign the value non-interactive to it. That way, apt will know that it can't ask any questions when installing packages because it's a non-interactive build.
Yeah.
So that it was just minor Linux.
Okay, yeah, but
remote.
that's a good trick. Yeah.
And then this one instead is more on focus on the topic. So Hinks one was asking about where details on the MPI installation in containers are. So I just mentioned that the base image you started from had already MPICH installed,
Yeah.
but I was wondering whether you could just detail a bit on that.
Yeah, well, we can take a quick look on that image on that Docker file in the Git repo. There is one link to the Git repo a bit down in the tutorial. So we'll come back into that. So okay, so we have our first image. We are not going to do too much with it.
There's one last question.
Yeah.
Sorry. From Akshay again. So he's asking about where we define any password because we're running this command as sudo. I guess this is why he's asking. So when we build a container, the Docker build command will need to be executed with sudo. So it will be a sudo Docker build. So that's the point where eventually you will be asked for a password to execute a sudo command. So that will happen as you type sudo docker build on the shell. After that, there is no more need for password during the build because everything in the Docker file is executed as sudo with root privileges.
So in point 4 above, if the nodes say Docker build, but if that fails because you don't have privileges, you will need to use sudo docker build. Yeah, I'm sorry for that. Just basically.
So every Docker build in this page, you will need to type sudo docker build.
Yeah.
And you won't be asked for any password because in this setup of our Nimbus instances, there's no password attached to the user input.
Okay. So you should have the new image 2.4.x01 in your list, your Docker image list, Docker image ls. Okay, so now we can go to Dockerfile 02. So Dockerfile 02 is a full Docker file, but it has a trick to break it, and also it still has commented the several packages that I mentioned before. So it is still not fully the real Docker file, but it's almost the complete recipe. So the problem with the WikiFOAM recipes that I show you that are available online is that those series of instructions are for you to install OpenFOAM using OpenMPI. And the main change to those instructions is to install OpenFOAM using the MPICH that has been installed in your system. So here are the parts in the Docker file to make that work. So I will try to go quickly through this. So basically, all these settings for telling OpenFOAM that it's going to be using MPICH instead of OpenMPI or instead of the defaults are in one file that is called the bashrc file. But we are going to also make use of another file named prefs.sh to define some other variables. So basically, I'm saying that this variable is going to keep the path to the prefs.sh file, and this variable is going to keep the path to the bashrc file. And then the recipe manipulates those files. So in the case of the prefs.sh file, that file does not exist in this path. There's an example of it that is under this other path. So basically, what all this run does is first takes the first 23 lines of that file, of that example, just to keep the format of the files as OpenFOAM does. OpenFOAM, in most of its files, has a header saying the version of OpenFOAM, etc. And those are the first 23 lines. So basically, I'm taking the first 23 lines and I'm putting them into this new file, OFPrefs, which is basically the prefs.sh. So I'm using here just one sign of greater than, which is basically a pointing that output here and to create the file. The rest of the outputs are redirected to that file with the double sign to append into what exists in that file already. If you use just a single sign, it will recreate all the time a new file, a new file, a new file. So basically, new file the first time, and then append into that file. Okay, so I'm adding just a line, but here is the important part. So I'm saying, I'm using the command echo to basically send into this file this text, export wm mplib system mpi. So basically, I'm setting these variables to the ones we need to use for using MPICH. So we are telling OpenFOAM that OpenFOAM is going to use the system MPI. We are telling some other variables that are difficult to explain, but basically, in this case, where is that system, well, that MPICH installed, and then flags that are going to be used during compilation for using MPICH. Yeah, it is here. So information for doing this is not in the wiki recipe. So I found it. So I'm putting here the links of where I found this information. So here is a link of discussion about how to use an MPICH. That's where I found this. But also there is a file inside the OpenFOAM installation that guides you on which settings you need to define for those files. But basically, this has worked most of the time for different versions of OpenFOAM that I have tried. And you can still check the examples of the Docker files that are in our Git repo to figure out this out and how to set these variables. Okay, the other part is to make changes into the bash RC. So bash RC, this is different because bash RC already has something inside. So it already has the foam install variable defined. So basically what I'm doing here with this series of set commands is to replace what is inside the bash RC file for the foam install and change it to what I want. So basically foam install needs to now be defined as the directory of the installation, which is /opt/OpenFOAM, and also the WM project user dir that we comment a little bit about it yesterday. So it's already defined for some place, and we are redefining it to be under home, OF user, and the version. So basically, well, we are redefining those places. I don't know if I had the whole definition here. And I think that is the most important change in the recipe, to basically allow the installation to use MPICH instead of OpenMPI. So yeah, I don't know if there are questions here. So as you can see, this is one of the issues with the Docker recipes, that it's not interactive. So you need to put everything written in your commands. And we are basically executing all. It will be nice if you can go to the files and edit them and then come back and be happy to keep working. But in this case, we need to use these set commands and these echo commands to make all the edits in the files that we need. So it's indeed a bit of a trial and error. Usually what I did was to test an installation live interactively and see which commands I needed to execute, how the files need to look, and then figure out how to use the echoes and the set commands to edit the files and have them ready to go for the recipe. But now, just Michael.
So there is one question on the chat by Natalie. It's possibly better if you read it because it goes a bit in detail of the syntax you just showed.
Yeah. Oh yeah, well, it's a little bit complicated, but I will focus down here in the changes to the PyRC. So just to let you know what this means. So this set-e means I'm going to replace the interior of a file, and then this command is looking to a foam install word that appears inside the file, and this sign means the beginning or the first column in the file, like the very beginning, like the total completely left of the file, the first character of each line. Well, not the file, but of a line. So it's looking for a line that starts with foam install. And once it finds a line that starts with foam install, this part of the command says, in the next line, write foam install equals to whatever equals. Yeah, it's a complicated command. But at the end, it's going to put foam install equals the value of this installation dir. And then the next line looks for the first appearance of the foam install word in the file, and it's going to replace it and add a comment to that line. So we are going to inspect those files later, and you will see the final end, the final result of how those files look. But basically, I'm using two set commands because I wanted to keep the original setting there just to be visually available and see what was the original setting. So basically, the first line finds the foam install and writes below what I want. The second line finds again the first foam install and comment it. So now what we have is the original line commented and then the new line just below.
And there was just a question about whether these parts of Docker files that we saw are in the OpenFOAM Docker file or in the MPI-based Docker file.
Okay. So these are in the OpenFOAM Docker file.
And then we have another couple. So this is quite a good point. So we've seen in these commands that you are editing the bashrc in the system, in the Docker file, and Inks1 was a bit confused because she says, will we have the right to modify bashrc, say on HPC?
Yeah.
And I think,
yeah, okay. Yeah, that's good. So this recipe, you have the right to modify whatever you want in your own installation of your image. Indeed, you are root in that installation. And that's it.
So all of these is happening in the container. It's not happening in the host machine.
Exactly. All this is happening in the container. And at the end, when you go to the HPC and execute OpenFOAM, yeah, you will use the files that are inside the container, and you are not touching anything about the installation of the HPC system. But your question is important, because at the end, it is all about security, and that is a hot topic for the use of containers, because you could have problems because users are root in the containers. And I think there was a time where users inside the container were able to modify files of the host system. So that's a hot topic. But in this case, we are not modifying anything in the host computer, and we feel really safe that the Singularity containers are not allowing people to access any kind of file systems of our computers anyway.
And one last question, if we have time. Leaf and Chen asking if we can edit these files directly, or it needs to be done in a scripted way in the Docker file.
Yeah, there are many ways of building Docker containers. So indeed, the first images I built with Docker were done interactively, like basically trialing an error inside interactive session of Docker, installing stuff there. And when the things finally worked, then basically that session, that container session of Docker, can be saved as an image. But we are not showing this here. That has a major problem, because then no one knows what you did to build that container, or well, that image, and then you don't have reproducibility of your process. So at the end, the learning process is always going around. So you will need to do some interactive commands to figure out what you need. But at the end, once you figure that out, you go back to a Docker file and put that in a recipe like this, and then test that that you got the same results. Basically, that's the process. But at the end, the idea is to keep building your Docker file recipe to have all these commands listed, because there's no other way to figure out how a Docker image was built. Okay, so I guess possibly we should have a break. So the next part is to build the second a second image, and it's a hands-on exercise to go to the breakout rooms. So if you take a look in the Dockerfile 02, you will find that, or if you execute the exercise later, you will find that it will stop with an error. And I wanted to show you this trick, because, well, that's the trick I'm using. Possibly Marco will correct me now with a better option. But inside the recipe, what has happened before is that I think I have the complete recipe ready and good to go, and then just send it overnight to build the image, and then test it, and it's not working. And I don't know where it's failing. And then I need to execute the recipe up to a certain point that I want to test. And the rest of the recipe I want to not to be executed. So again, I finished with an image, so the process didn't break, but that image is not working. So then I need to come back to the recipe, and the recipe is full. And possibly I want now to break the process at the middle of that. So one option is to edit your Docker file and basically comment the rest of the Docker file, and then all those commands will be not executed. But what I'm doing is to put a command that will break with an error. So I put at a certain point, at the point I want the process to stop, this command, run stop here, and then the process will break. But still, because of the layer building of Docker, all the commands that were executed above will build a layer that can be used as an image and can be tested. So that's the trick. So I hope you find it useful. Yeah, so in this part, more on the Docker file here, or obviously you can look the Docker file itself. But here the MPI root is where we are, where we tell OpenFOAM where to find MPICH, or in this case, the system MPI. I don't know if there are any other questions.
Yeah, there's an interesting question by Natalie on the chat.
Yeah, Natalie has a question here.
What were the definitions of the tags when we went into interactive container mode -IT-rm?
So where did you pick that?
Okay, I put that because, well, IT means interactive. So that means you go into a session, interactive session, and you can be inside the container. And the -rm tells Docker to basically kill the container when you exit. It's just that Docker leaves those containers, those instances of containers alive. So even if you exit, the container is still alive in the Docker engine. And then if you don't realize that, and if you execute that command again, that will open a new container and then a new container, and then you will finish with a lot of processes alive in the Docker engine that you basically don't know about them. So the best practice I use, and I think Marco also uses it a lot, is when you go interactive, you set the --rm so that in principle works as my head works. Like if I exit something, that is gone for good.
Yes, apparently in the IT world, this is not the preferred default behavior, so we need to specify it ourselves. So we didn't talk much about Docker options during the webinars because it was a bit off scope, but there is, so the second last episode in the webinar tutorial online has a bit more examples on this syntax.
Great.
Okay. So I'm going to go to section F in the tutorial, which are, so the recipe is huge, so there is a lot possibly to comment, but at least the final remarks I want to comment on the Docker files are, well, this one. First, our Git repo where the recipes are. So that is that one. I'm going to click to this link. Okay, so that's where we keep all our recipes for different containers and different applications. So we are trying not to put too much there, just to reduce the amount of things we are going to maintain. So here is the one where is the recipe for building MPICH, and you can take a look to that Docker file. The only thing I'm going to comment here is that we are saying that this image is going to be built from Ubuntu, and from Ubuntu version 18.04. Obviously, this is not the recipe we used for the exercise you have just done, because that's 16.04. But what it means is that it is the same recipe for 16.04. You just need to change this argument and change it to 16.04, and then you will build that MPICH base. But that is indeed already built. I I will show you in a minute. But first, I wanted to show you the part of OpenFOAM. So that part of OpenFOAM has two directories. One is basic installations, and the other one is installations with additional tools. So in the basic installations, you will see the recipes for the different versions. Unfortunately, to change from version to version is not as simple as just change the version as for MPICH. In this case, each recipe is different, really. So you have all these examples, and our hope, in particular my hope, is that you will be able to build your own containers following the examples of here and following the recipes in the wiki, FOAM, and I'm hoping to be good enough for you to build any other container for any other version. Okay, okay, so the full Docker file. So inside of each directory, you have these two subdirectories, the Docker and the Singularity. And inside the Docker, you finally find the Docker file. So this is the full Docker file without stop here or anything. So it's good to go. So you can clone this repository and use this Docker file to build version 2.4.x with the commands we have just used, if you want. What else? Oh yeah, this is one of important things. So in the other directory, installations with additional tools, I only have one example, and that is for OpenFOAM 5.x with this additional tool that is called CFDEM. So we are not doing it here, but I'm just going to show you that what is the recipe for building that. And that is useful for many. So basically, that recipe that starts with the original installation of OpenFOAM 5.x. So basically, on top of Pawsey OpenFOAM 5.x, then you can install whatever extra stuff you want to have installed in your image. In this case, all this own recipe is for installing stuff to make CFDEM and this other package to work. So it's basically continue the process of installing stuff from what you had originally from the old previous recipe. There is only that one example.
Excuse me.
Excuse me. Yeah, sure.
Okay, Alex, I think I may have a question because this is what I'm working on currently, this CFDDM.
Yeah.
So I was wondering when I tried to build an image for this, because this has a lot of dependencies and other libraries was included, which you may realize that they need the VTK library and the other things like PowerView or something, you know, they also, yeah. So I wonder how you handle that when you build these images. I mean, like, did you also include all those stuff in this recipe or not? Or it's just like OpenFOAM, like CFDDM or?
Well, this one was done a while ago, but I just follow indications from what needs to be done to install. So anything you do to install it in your normal Linux environment, you can do it in this recipe. The only difference is that sometimes you edit files in the normal environment, and here you need to modify the files with single line commands. and you create all these links. So
I
here
think
is the
VTK
part,
is installed here. I think.
here is the part for the VTK, linking to what exists there of the VTK in ParaView. Yeah, I'm not going to discuss the specifics here. I just wanted to show you this, but we can discuss about that later if you you contact me in the containers channel or
Yeah, sure. Also, so here you use MPICH or just MPI? Like,
oh no, that's still MPICH because that is exactly the important thing I wanted to show you. So all this is built on top of an already existing container, which is OpenFOAM 5.x.
Okay, I see.
And yeah, and that OpenFOAM 5.x is a Pawsey OpenFOAM image, and that's by default with MPICH.
Okay,
Yeah.
thank you.
Yeah. Okay, so that's the thing I wanted to show you in our Git repo. I should have opened this in another, which section we were? F. Yeah, we have the Docker images in Docker Hub. This is a link to the wiki instructions. Again, those instructions are fantastic. Only issues that are for OpenMPI, so you need to make these tweaks to use the MPICH. Okay, so the final comments in the Docker file are these two parts, which are the commands for installing or for compiling the third-party tools, compiling OpenFOAM itself. So basically, to compile OpenFOAM or the third party, you basically execute this script all make. But first you need to be in the proper directory. And first you need to source the bashrc file. So these two lines are, or two sections are one after the other, I think, in the original Docker file. And the comment I wanted to say is that for each of these commands, you need to source the bashrc file. So it's sort of each run command is its own shell, defines all the variables there, and then after ending the run command, all the environment variables are lost. So you need to source it again every time you need the whole OpenFOAM environment. Basically, the first part of the command is sourcing the bashrc file. That's the comment I wanted to do here. So now in your terminal, you can try to do these commands, but unfortunately, these commands will break, so will not work. But I'm just showing the general structure. I'm missing the sudo part at the beginning before Docker. But the idea is once you have a recipe, you just execute sudo docker, where I am. Yeah. Sudo docker build. Ideally, yeah, that final recipe should have the official name Docker file. So we don't need the -f to indicate which file we're going to use. We don't need anything. So we'll use by default Docker file. And then your Docker Hub account, the name of your container or your image. And in this case, well, it is failing because we don't have the Docker file there. Again, this point 1 in the tutorial is to show you the right command to build. I know it's confusing right now, I'm explaining it. If the real Docker file were there, then it will go and reach completion. So once you reach completion after 6 hours of compilation, or more or less, then you need to test it. So that's what we are going to do right now. But instead of testing the my user OpenFOAM 2.4.x, the one that in theory we were building, we are going to test the one that is working, the Pawsey OpenFOAM 2.4.x. And that container is already pulled into your Nimbus instances. So you should be able to execute it. So let's do it. Docker run interactive session, remove after exiting, --rm, and then call the image from Pawsey OpenFOAM 2.4.x. So now you are inside the container, and we need, oh, here it is. We need to source the bashrc file to have our environment. So we need to do source opt OpenFOAM. That's the place of the installation. OpenFOAM 2.4.x etc bashrc. So you can, for sourcing a file, you can use the command source, or you can use the dot as in the recipe here. To sourcing, I'm using dot. I think the Docker builder only recognizes dot by default, so that's why I'm using dot in the recipe. Okay. So after sourcing the environment, I should be able to go to where the OpenFOAM variables are set. So cd $foam tutorials. So I can go to tutorials, see what's there, what is there. Then let's go to the tutorial we have been working on. So cd incompressible PimpleFOAM channel 395, and that's the tutorial we have seen in the past, although this tutorial is a bit different because this tutorial is for version 2.4.x, so it has some small differences to the tutorial we worked yesterday. And here you see the script all run. You can do whatever command you want, for example, block mesh, and it will basically run. Or you can do execute that script that executes everything. So it will start running the block mesh, the decomposer, PimpleFOAM. So basically we are using the tutorial and we are seeing that OpenFOAM is working. So basically it's passing the test. So everything is working fine. Now it will take around 15 to 30 minutes to finish this solver. So we need to kill it with Control-C because basically we just wanted to test that OpenFOAM was working correctly in the Docker image.
Alex,
And yeah.
yesterday we were using 4 processors in the tutorial.
Yeah, this tutorial is different, and that's one of the differences. This tutorial for version 2.4.x was originally prepared to use 5 processors.
We have a question, we have the golden question here from Felix. Is there a way to automatically source the OpenFOAM bashrc when we execute the image?
I think for Docker you can find some tricks. When you do it interactively, but it has always been difficult. Really, we have tried many possibilities, and I think the best way is just to to do it like this. Yeah. What else? The other thing is that if you see, we are working inside the container, and you see this, that it already created some files. So all this is being created, and Marco can help me with this. So all this is being saved in some temporal space. And when you exit the container, that information will be lost. Yeah. Indeed, we are not modifying the image. So that's one of the differences between image and container. So the image is clean. This container that we're executing is now not clean. But it's not here our purpose on how to deal with Docker runs, but you can figure out how to save your results or etc. Basically the same process of binding external directories to the container is the way to go. In this case, I just went directly to the tutorial, executed it, because again, we are just testing it. We are not caring about the results or anything. So we can exit. So then the image is working. And the final step is to push the image to the Docker Hub. This is the way you push an image to the Docker Hub. You need to have a Docker Hub account, and then your image will go up. Here, again, this will not work for you, but at least you have the command there. And final step is to convert the image to Singularity format. So now we need to go to the other directory. ls cd02 porting to Singularity. There you will see that we have a definition file for Singularity. And well, we can execute that command. So that the command for building with Singularity, I will show you the recipe in a minute, but I think it's better if you execute the command now. So it's sudo Singularity build. Then you put whatever name you want. So the convention we are using here is OpenFOAM, then the version, then the creator, .sif. As you remember, the image in Singularity are just a simple, at the end you will get a simple file. And then the file of the recipe, singularity.def. So that will start building our Singularity image. And as you may wonder, that Singularity image is built from the Docker image we have. So let me show you the definition file. So the definition file, in this case, because we're building pretty much everything in Docker, is basically a very simple definition file for Singularity, which is use Docker. That means that it will go to the Docker Hub and pull or search for an image named Pawsey OpenFOAM 2.4.x. And then from there, it's going to convert it and do whatever is in the recipe. And in this case, in the recipe, the only thing we have is, I'm using again the same trick, using the echo to write something into a file. in this case, that file is a file that saves some commands to be executed every time you open a session with a Singularity image. So here we are doing the trick of basically source the bashrc file every time we open a Singularity image. So we are not doing that in Docker because it's difficult. We have not figured out an efficient way of doing that. But there is an efficient way of doing that in Singularity, so we are taking advantage of that. So yes, for the Singularity image, we write a line into the file defined by this variable, but that file is going to be execute this command, which is source the bashrc file, and that's it. And these two lines above, we need them because the bashrc file has some specific language that is only understandable by bash, the bash shell of Linux. And originally, the commands in this file are going to be executed in dash or sh environment, which is different to bash. So basically, the first two lines are to change the shell environment inside the section of building the Singularity container to be able to understand the bashrc. So that's all from Singularity. And yeah, it will take a little bit of time.